Wilson Corporation has an outstanding bond with a par value of $1,000 that's maturing in 12 years. The interest on this bond is paid annually, and the coupon rate is 10%. So right away we can tell that with a coupon rate of 10% and a par value of 100, this bond must have an annual coupon payment, par value of 1,000, this bond must have an annual coupon payment of 100. That is 1,000 times 0.1 is equal to 100. The bond is currently selling for $850. What is the yield to maturity? So what information we can gain thus far is that the par value is 1,000, but this bond is for some reason selling for $850. And the reason for that is the cash that this bond pays versus the cash that if we bought a bond in the marketplace. Since our bond pays 100, we must assume that the bond in the marketplace is paying more than 100 given the current price. What this is saying is that this bond that's now selling for $850 is the result of an increase in market rates. That is, the price of the bond has dropped so that the person who purchases it in the future will then receive the yield in the marketplace. So to figure out this question, we can start out by looking at a series of cash flows where at time 0 we receive negative, or we have an outflow of $850, and then we have cash inflows every year in the form of the coupon payment of $100 for the next 12 years. And at the end of year 12, there's a return of principal of 1,000. Below you'll see the total of cash flows. Now there's two ways we can solve for this. Now if we were to try to solve for this by hand, where we're solving for R, it's really impossible. We can minimize or simplify the equation, but we get down to the point where solving for R basically becomes a guessing of higher and lower. That is, we can't algebraically solve for this. So to use Excel, there's a couple of different ways. We can come up with a hypothetical discount rate, and since we know that the bond right now is paying 10%, let's try a discount rate of say 11%. So we can use the NPV formula, and we'll just use this guess rate of 11%, and then we'll include all of the cash flows from year 1 into the future, and then we also have to add in the cash outflow at time 0. So right now we can see that there's still a positive NPV, and what we're trying to do is get this to 0. So we can do a couple things. We can guess to try to get to that point, or we can use a tool within Excel called Solver. And the two ways we can get to this are either via data analysis, or we can use go into what if analysis and select goal seek, or we can go in analysis and use solver. But we'll use goal seek. And so what we're going to do is we're going to set our NPV value to a value of 0 by changing the discount rate in T11. And so we can see that the discount rate is approximately 12.475%. There's also another way you can go about this. It's using a function that you haven't learned yet, which is the IRR function. So we'll just type in =IRR. We'll get all of the values. We won't enter a guess value. And we can see that we also come up with the 12.475%. We can also use the rate function. We'll go =rate. We get the number of periods, which is 12. The payment is our regular coupon payment. We know the present value, which is the negative $850, or the cash outflow. The future value is the return of principal that we expect. The type refers to whether if this is cash flow at the beginning or the end of the period. It's at the end of the period, so we type in 0, and we're not going to guess. And again, you can see we get that 12.475%. So there's 3 different ways to go about finding the yield to maturity in this situation. The first route using MPV is a little bit long-legged, but it gets you there using solver or goal seek functions. You can also use the IRR function in Excel, and you can also use the rate function. So I hope that helps.